So before we were introduced to all the GPT-5 and the current best of the best models, we had something known as the BERT era. It was the pre-GPT-3 era. We have seen a GPT-2, a decoder-only transformer, very simple. We've also seen it in very detail, especially the architecture in the last video. So this video, we're going to go in a chronological order and discuss what was the BERT era, the pre-GPT-3 era. In the next video, we're going to discuss things like context learning or in context learning. And in the further video, we're going to discuss the weekend white paper where we show what the paper of GPT-3 described. The large language models are few short learners. What did that paper come up with? What does it teach us? So here in this particular era, when we were introduced with attention is all you need, we are exploring something like BERT. We are getting accustomed to the idea of very large parameters, millions and billions of parameters. Then we are also exploring something like scaling laws and power laws. So we will eventually arrive to that particular, inference or conclusion, like what did scaling laws teach us and what did power laws teach us. But right now, where we are stuck at, so we have introduced attention, right? Now, after introducing attention, transformers became very famous in the whole natural language processing domain. Why did they become famous? Because recurrence was being replaced by the idea of attention. People were trying to implement it. We had multi-headed attention and we were able to parallelize all the computation. So that kind of unblocked us on multiple ends, right? And we were able to see that from the raw text we are able to represent or produce a generic linguistic representation of the whole language, right? One breakthrough or one good paradigm shift that happened was the idea of unsupervised pre-training, right? So what we used to do, we used to train a very large model, especially during the time of BERT. We used to train a very large model on enormous amount of text, right? So it was self-supervised training and unsupervised training. So we did masked language modeling. We used to take that pre-trained model and then attached a task-specific output head, right? Or a domain-specific output head, which basically introduced the notion of fine-tuning. So now we had this fine-tuned model. We imagined that unsupervised pre-training or unsupervised learning is great for producing raw text to generic linguistic representation. Then we will do fine-tuning or task-specific tuning for our particular use case, right? So this was the paradigm and this was what was being followed, right? So BERT kind of helped a lot at that time in producing these contextual representation. Then unsupervised pre-training was also, a very likable concept, but we still needed the labeled data set. So it was like it's good to have a large base model. It's good to have a large brain, but whenever you want to do something important, something useful, like maybe simulate question and answers, we need QA pairs of labeled data set. Let's say we want to do sentiment analysis, we will use BERT to produce representations, but we would still need a labeled data set of sentiments, right? So this was the paradigm. There was a big need of labeled data set, and BERT was also being used to produce large linguistic representation from raw text, right? Then the GPT-3 paper introduced couple of things that kind of helped engineers, look at scaling laws, look at power laws, and look at the idea of in-context learning. I'll cover in the next video how fine-tuning kind of started getting diminished. At this point, what we are doing is we are taking a large model, fine-tuning it for our domain-specific use case using the labeled dataset. That large model might have been produced from unsupervised learning, fine-tuning with a lot of labeled dataset, which is, with complete supervision, and then solving that objective. Let's say the objective is to simulate question and answers, the objective is to complete sentiment analysis. So this is the workflow, right? Now we'll see in the next video, especially before we discuss the white paper of GPT-3, we'll see that how we are evolving from this fine-tuning paradigm to a paradigm of in-context learning. How did we observe that we don't need to always change the weights. We don't always need to undergo gradient descent. We don't always need to do back propagation. We have something known as activation. We have something known as the forward pass. And when we produce a very large model, like a 175 billion parameter model, we have something known as in-context learning as a concept. And in-context learning will help us understand the idea of zero-shot learning, few-shot learning, and one-shot learning. And I mean all of these three paradigms, zero-shot, one-shot, and few-shot, and how in-context learning is more than enough for you to do, a lot of your domain-specific tasks. And you don't need to fine-tune and produce a family of models at every particular use case. So we're going to discuss in context learning in the next video. And in the further video, we are also going to discuss the white paper, the weekend white paper, which is large language models are few short learners. Then we will, dive deep into the idea of GPT-3. Thank you.